Chapter 6 Sample Problem 5. According to the static friction coefficients and the block mass in the picture, determine the maximum value which P may have before any slipping takes place. As we can see, the upper block is prevented to move with the cable at the end of the block, so the two other blocks can slip with the applied force in the picture shown, and also maybe under their forces due to the gravitational effects. So we can sketch the free body diagram for each block. Consider this picture again. We have 3 blocks. First, we assume that the middle block is impending to move down. So the middle block's free body diagrams can be sketched as this picture. We have a force P here. Let me if the block is impending to move down, the two friction forces are in the opposite of the direction of movement. So the first is in this direction, and second also is in this direction. We have a force due to the gravitational force effects here. The contacting forces are two. The first contacting between the upper block, and the second contacting is for the lower block. So a P here, P, two forces, friction, contacting force, and gravitational effect force. We can name the F1, F2, and N1, N2, M2G. Like the middle block according to this picture. Yes, middle block, upper block, up block. Free body diagram should be related to the forces shown in the middle block. The contacting surface of the force is the opposite direction with the friction force F1 considered is in direction, and the opposite of this force applied on the upper block, and a force due to the gravitational effect, and also a force T that caused due to the presence of the cable here. Now we have these forces in the upper block. Force F is in this direction, and T. F1, N1, T, and M1G, the up block. The down block, lower block, or according to the lower block, we have a force due to the gravitational effect, a force opposite to F2, the force between the middle block and lower block in the opposite direction of F2 in this direction, and the contacting force here. There is no another force. There is another force between excuse me, it is in the direction, in the opposite direction with the F2, another friction force with the bottom, the ground, and the lower block. We have a contact force here, a contact force here, and there is no another force in the lower block free body diagram. The direction of forces are the opposite to the assumption here. N2, N3, M3G, F2, and F3. With this assumption, we can write for each block in the y direction sigma Fy equals to 0. For the upper block, three kilograms in the y direction. We choose y direction in this directions for each block. N1 minus M1G cosinus theta equals to 0. N1 equals to, for the, we calculate N1 here, so now we can calculate N2 with this diagram for the 50 kilograms. N1, N2 minus N1 minus M2G cosinus theta, N2, N1, N2G cosinus theta, which is for the another block. Like 40 kilograms in the y direction, we have N3 minus N2 minus M3G cosinus theta equals to 0. So N3 equals to N2 plus M3G cosinus theta equals to Newton. Now we are going to calculate the friction forces. The first friction force can be calculated from the upper block free body diagrams. For up block, we calculate N1. Now we can calculate the we can write the sigma fx equals to 0, which is f1 minus t and minus m plus m1 g sinus theta equals to 0. We will assume arbitrarily that only the 50 kg block slips so that the 40 kg block remain in place. Thus, for impending slippage at both surfaces of the 50 block kilogram, we can have these relations for the kilogram blocks. Consider this picture. So if we assume that only 50 kg block is impending to slip, so we calculated N2, N1 and N2. So F1 US N1 equals to and F2 with this relation we can, for this block P can be calculated. So with this P we are going to check if the lower block move or not. Consider the free body diagram for the lower block. The free body diagram shown N2 calculated before and is N3 excuse me, N2 is and N3 F2 US between the up lower block is 4500 multiplied to now we can check the result. If the movement in happened, F3 should be calculated. If our assumption is true, we can check the F3 max with the obtained F. At first, we have in the x direction F2, F3, F3, F2 plus N3G sinus theta. F3 F3 max equals to greater than F3 max. So this force cannot be supported and initial assumption was wrong. We conclude therefore that slip occurred first between 40 blocks and the inclined with the corrected force. So our assumption that the middle block is bending to a slip is incorrect. So we are going to calculate our computation with the F3 equals to the maximum 459 with this free body diagram. With this free body diagram, we can start sigma Fx equals to 0, F3 in the direction shown, minus F2 plus F2 plus M3G sinus theta. F2 can be calculated from this relation. With this F2, we are going to use this force in the free body diagram of the 550 kilogram block. Consider this picture. With this picture, F2 calculated. So we have P minus F2 minus F1 minus m2g sinus theta. F1 calculated before. P equals to the maximum force before any slipping occurred.